Hi, my name is Gan Pei from 4B KG Section 3. Now I'm going to present my final year project. My title is Accelerated Aging on Different Transformer Insulating Oil Types. Here's the content that I'm going to show in this video. Now I'm going to talk about the background of this project. What is transformer oil? Transformer oil is used to provide the protection on the paper insulation and to act as a cooling agent in the transformer. It is used for preventing the arcing shocks and the corona discharges in the transformer. What are the criteria for choosing transformer oil? It must have strong dielectric strength, high thermal stability, and high resistivity towards oxidation to prevent the degradation of quality in transformer oil. What are the failures that may occur in transformer because of the aging in transformer oil? First is winding failures. Second is dielectric faults. Third is bushing failures. Fourth is core failures. And fifth is tank failures. The first problem statement for this project is the transformer insulating oil commonly used is mineral oil. Mineral oil has low flash point and it is not eco-friendly due to its limited biodegradability. And the second purpose statement is most of the previous researchers had shown the degradation in quality of transformer oil. But from the researchers were investigating only one or two types of transformer oil under different conditions. The first motivation for this project is due to the limitations of using mineral oil. Natural ester oil is suggested to be used as the transformer insulating oil. This is because natural ester oil is derived from renewable vegetable oil, which is more eco-friendly compared to mineral oil. Natural ester oil also contains higher resistance toward high temperature. The second motivation for this project is the comparison among more different types of transformer oils under the same conditions is suggested to be carried out to obtain more information about the properties of different kinds of transformer oils. The first objective for this project is to investigate the properties of mineral oil, palm-based oil, and rapeseed oil after accelerated thermal aging process. And the second objective is to study the behavior of various transformer insulating oil after accelerated thermal aging process. And the third objective is to evaluate the performance and response of the mineral oil, palm-based oil, and rapeseed oil after accelerated thermal aging process. Now, I'm going to talk about the scope for this project. The oil samples used in this project are mineral oil, palm-based oil, and rapeseed oil. The aging catalyst used in this project is pure copper powder in 1.5 gram. The temperature used for thermal aging treatment is 120 degrees Celsius. The thermal aging treatment is carried out up to 1,500 hours. The AC breakdown voltage and the dissolved decay products for each oil samples are tested at 0 hour, 100 hour, 250 hour, 500 hour, 1000 hour, and 1500 hour. For breakdown voltage test, the test standard used is ASTM D1816. For UV test, the test standard used is ASTM D6802. Now I'm going to talk about the literature review of this project. First, I'm going to talk about the insulating materials used in transformer. There are two insulating materials used in transformer. One is insulating paper, another one is insulating oil. Insulating paper provides the excellent dielectric strength and less dielectric loss. It can be wrapped easily around the coil and be made of different dimensions according to the requirements. And it has hygroscopic properties, which mean that it will absorb the moisture content around or in the surrounding of the transformer. For insulating oil, mineral oil has low viscosity and it is a good cooling agent, but it is non-biodegradable and non-renewable. For palm-based oil, it is originated from palm oil, which is renewable source, so that it is more eco-friendly. It has less viscosity than mineral oil and it also has a high stability towards high temperature, so that it can reduce the speed of degradation of transformer oil. Next is rapeseed oil. Rapeseed oil is kind of vegetable oil for cooking purpose. It is non-toxic and high biodegradable. It has almost similar electrical properties with mineral oil under the same moisture content level, so that it is suggested as alternating transformer insulating oil. Now we are going to talk about the conditions that affect the aging process of transformer oil. The first conditions that may affect the aging process of transformer oil is temperature. The degradation process occurs when the temperature of the transformer insulation system is increased. Breakdown voltage is decreased with the increase in temperature. And also, the moisture content level is increased and the dielectric constant is decreased when the temperature is increased. Next is acidity. The presence of acidity in transformer oil is due to the oxidation in transformer insulating oil and the hydrolysis process of insulating paper, and it will produce the impurities in transformer oil and increase the aging process of transformer oil. Third is moisture. The presence of moisture content in transformer insulation system may lead and accelerate the aging process insulation system. And the last is presence of aging catalyst. The catalyst will increase the speed of degradation of quality in transformer oil. The catalyst will react with the free radicals and form insoluble decay products in the transformer oil. Now I'm going to talk about the dielectric characteristic test that may detect the decay of transformer oil. First is breakdown voltage test. This test is to test the dielectric strength of the transformer oil. The breakdown voltage of an insulator is the minimum voltage that causes a portion of an insulator to become electrically conductive. The factors that may affect the breakdown voltage are moisture content, temperature, and aging catalyst. The lower the breakdown voltage, the more the impurities in the transformer oil. Breakdown voltage is increased with the temperature of the transformer oil. The breakdown voltage of natural ester oil are higher than mineral oil. Second, moisture content test. This is used to test the moisture content in the insulation paper. Water saturation limits of natural ester oil being very high so that it can hold more water. Also, due to hygroscopic nature, water remains in liquid instead of migrating to solid insulation, which extends the life of the solid insulation. The moisture content in rapeseed oil is higher than that in mineral oil, and the reason is that the increase of moisture content will lead to the increase of dielectric loss. Third is dissolved gas analysis. This is used to check the health of the transformer. Whenever a transformer undergoes abnormal thermal and electrical stresses, certain gases are produced due to the decomposition of the transformer oil. The gases found in the oil in service are hydrogen, methane, ethane, ethylene, acetylene, carbon monoxide, carbon dioxide, nitrogen, and oxygen. Fourth is UVB test. UVB spectrophotometer is based on the absorbance of the light by the transformer oil to detect any abnormalities in transformer. UVB spectroscopy may detect the free radicals, which is dissolved decay products that will increase the speed of aging due to the oxidation. From the research, the rate of dissolved decay products in mineral oil is higher than in natural ester. Now I'm going to talk about the methodology. Before the thermal treatment process, the preparation of aging samples are done according to the steps below. First, prepares the insulating oil and paper samples. Second, measures the initial conditions of the insulating oil samples. Third, cut the insulating paper into desired shapes. Fourth, prepares the insulating papers and press board for each 800 ml insulating oil. Fifth, prepare the bottles for the aging treatment. 6. Immersing process into the bottles under room conditions for 24 hours. And the last is put the samples into the oven for thermal aging treatment. The first experiment to test the aging in transformer oil is breakdown voltage test. The test method standard is ASTM D1816. The tester used is Mega OTS 60PB. This slide shows the breakdown voltage test procedure. The second experience to test the aging of the transformer oil is UVB spectroscopy test. The test method standard is ASTM D6802. UVB spectrophotometer used is Shimazu UV1800. This slide shows the UVB spectroscopy test procedure. Now I'm going to talk about the result and discussion. This table shows the mean of breakdown voltage for each type of insulating oil. We can see that from the table, the breakdown voltage for all types of oil is decreased. But the rapeseed oil still remains the highest among the other two types of oil throughout the whole thermal aging process. This graph shows the difference in breakdown voltage of mineral oil over time. This graph shows the difference in breakdown voltage of pump-based oil over time. This graph shows the difference in breakdown voltage of rapeseed oil over time. By comparing the two previous graphs, the difference of breakdown voltage of mineral oil is the highest compared to pump-based oil and rapeseed oil. This shows that the speed of aging of the mineral oil is faster than the pump-based oil and rapeseed oil. By observing this graph, we can see that the rapeseed oil has the highest breakdown voltage even after 1,500 hours of thermal aging process, while the pump-based oil is intermediate and the mineral oil is the lowest. So this proves that the speed of aging of the mineral oil is faster than the pump-based oil and rapeseed oil. This table shows the mean of relative content of dissolved decay products DDP for each type of insulating oil. We can see that the relative content of DDP in all types of oil are increased. But for rapeseed oil, the relative content of DDP is increased at 1,500 hours. This is because of the sludge formed in the oil. This graph shows the difference in relative content of DDP in mineral oil over time. This graph shows the difference in relative content of DDP of pump-based oil over time. This graph shows the difference in relative content of DDP of rapeseed oil over time. By comparing two previous graphs, the difference in relative content of DDP of pump-based oil is the highest, but the relative content of DDP in pump-based oil is less than the relative content of DDP in mineral oil. From this graph, we can see that the mineral oil has the highest relative content of DDP compared to the other two types of insulating oil after 1,500 hours of thermal aging process. This shows that the aging speed of the mineral oil is faster than the other two types of insulating oil. In the conclusion, the thermal stability is the most important criteria for choosing the best transformer oil. The temperature may affect the oxidation occurs in the insulating oil and produce impurities. For the breakdown voltage, the difference of breakdown voltage of mineral oil after the accelerated thermal aging is the highest compared to pump-based oil and rapeseed oil. Meanwhile, the breakdown voltage of the rapeseed oil is the highest after 1,500 hours of thermal aging treatment. For the dissolved decay products, the difference of relative content of DDP obtained in pump-based oil is the highest, but the relative content of its DDP is less than the DDP in mineral oil. Both results shows that mineral oil has the fastest aging speed with compared to pump-based oil and rapeseed oil.